Let's talk about arc length in polar coordinates. So recall that in, I think it was section 10.2, we talked about the parametric form of the arc length formula. And that looked something like this. We had the integral from a to b. Remember, theta was our parameter. So we took the derivative of x with respect to theta, square that, the derivative of y with respect to theta, square that. This thing kind of looked like a Pythagorean theorem with really first derivatives inside there. Okay, so what we want to do is we want to basically derive a formula for arc length, but working with polar coordinates. So we know that our polar form has this r cosine theta, which is f of theta cosine theta, and the same thing for y. Y is r sine theta, which is f of theta sine theta. So I guess implicit in this is the fact that we have a function r is equal to f of theta, which is really what our polar functions look like, right? So we can use the product rule to write down what our dx d theta is. It's going to be the derivative of the first thing, which is dr d theta, keep the second, which is cosine of theta minus, and then we would get the derivative of the second thing, which is sine theta, and then we keep the first thing, which was r. So we've done this before when we calculated the slope of the tangent line dy dx. If we do the same thing with the y coordinate, you're going to get dr d theta, which is the derivative of f, times the second thing, which is sine theta. And then the derivative of the second thing is cosine theta. And we keep the first thing, which is r, put a plus sign in between those two. Okay. So now what we want to do is we want to find a formula for the what's inside the square root over here. So we need to basically do some algebra. So first, let's write down what dx d theta is. So our dx d theta squared, and we're basically going to be squaring this first thing here. Let's use the fact that a minus b squared is equal to a squared minus 2ab plus b squared, right? So if I apply that to the dx d theta, we're going to get dx d theta squared is equal to dr d theta quantity squared times cosine squared theta minus 2 times r dr d theta sine theta cosine theta plus r squared sine squared theta. Okay. So we also need a formula for the dy d theta squared. So in this case, we're going to use the quantity a plus b squared is equal to a squared plus 2ab plus b squared. So let's calculate what that is. You're going to get dr d theta squared sine squared theta plus 2 times r dr d theta sine theta cosine theta plus r squared cosine squared theta. And then remember, inside that square root, we wanted to add these two things together. So I'm going to put a plus sign over here, and I'm basically going to add both sides together. So let me move this up a little bit here like this. And let's put a line here. I'm going to add those two sides together. So we get dx d theta squared plus dy d theta squared. What's that going to equal to? When we look at that first part is going to be this first term, adding these two guys together. We get dr d theta squared cosine squared theta plus dr d theta squared sine squared theta. If you look at this term and this term, they're just the same term with opposite signs. So that part there is just going to be plus 0. And then when we look at the last two terms, that's going to be r squared sine squared theta plus r squared cosine squared theta. Okay. So I think we could see that we have some common factors here. So from these first two right here, they have a common factor of dr d theta squared. So this is going to be dr d theta quantity squared. And then we have a cosine squared theta plus sine squared theta. For the second guy, we have the second two, we have a common factor of r squared. So for that second factor, we're going to get r squared sine squared theta plus cosine squared theta. As we know, each of these two objects is equal to 1. That's our Pythagorean identity. So putting this all together, we're going to end up with the square root of dx d theta squared plus dy d theta squared is equal to the square root of dr d theta squared plus r squared. Okay, so if we plug all of this back into our arc length formula, we're going to get that the arc length is equal to the integral. We're going to go from alpha to beta square root of dr d theta squared plus r squared d theta. And this is our arc length formula. Let me highlight this guy. And we will work on an example together in class. All right? Take care, everyone.